Jose. Thank you to the University of Zaragoza, and thank you to all of you for being here. So it's my pleasure to be here, basically my maybe first lecture here. So that's very nice that we have new upcoming engineers in production and industrial engineering learning about digital technologies, which is basically the main reason why we have done this project, which is called DIGIMAN4.0. That stands for Digital Manufacturing for Industry 4.0. And that's us, and that was in 2019. So I will close the presentation with a bit of history about the projects, but I'll start with some information which is related to the project, and while I will explain the background, the motivation, I will put it in the context of what they call the fourth industrial revolution, which is called Industry 4.0. And as I said rightly by Jose, you are studying mechanical industrial engineering, this is basically the environment that you will be working on as soon as you finish your studies. There is no single industry which is not being digitized today. So with this in mind, we told to eventually to the politicians basically in Brussels, why don't you give us some money and some time to train the next generation of doctor engineers in production engineering. And the reason why they should have granted us the project, which actually happened, is due to basically the fourth industrial revolution, Industry 4.0. So it has been shown that there are a number of technologies right now, and for the past 10 years, in fact, that have been revolutionizing the world, and in our case, the world of manufacturing. And they are listed here. So we know about autonomous robots. They could be autonomous drones, but self-driving cars and self-automating equipment for production. We have a lot of system integration from the production floor up to logistics and everything in between, Internet of Things, sensors without wires anymore, so all connected to that's called the edge, the computer on the machine, and to the cloud. Simulations. Basically, everything is being virtualized right now. Additive manufacturing, also called 3D printing. Cloud computing, since we are producing bigger and bigger modules, because now it's not a single process, then it's the machine, then it's a number of machines, then it's the entire factory, up to many factories around the world. We need bigger and bigger computers that cannot stay in our table anymore. So that's in some data centers, and they are connected with the cloud. Augmented reality, you will see more about that later. Big data has to do with the fact that with so much sensors, a lot of data is produced, and is produced more every day. What do we do with all this data? So a special type of profile, this is the story we are bringing on now. We need new people like you and like our DIGIMAN 4.0 researchers that know about material science, they know about production engineering, and they know about data science and statistics. And with everything which is in the cloud, cybersecurity, which is a technology that we have been using but not doing research on, but basically is the life insurance that Industry 4.0 actually works. Because when hackers are hacking a digital system, they can take over an entire factory, company, etc. Good. So we are living in the digitizing, decade, but we are not digitizing just for the sake of being digital. There are a lot of measured advantages of being digital. And here you can see a quick list, and I'm going to only mention the numbers. and the main use. So if we digitize, then we can model, and then we can predict when our machines, in general we say any physical assets, needs to get maintenance. So what we want is to maintain a system right at the right time. If we do it too early, we interrupt the production too many times and we lose time and productivity. If we do it too late, then the damage can compromise the asset, and that's millions of euros of damages, or at least we produce bad products that needs to be thrown out. So how to predict the right time we need to do maintenance? That's predictive maintenance, and that can be done only with digitalization. Then we have human-robot collaboration, so a new type of robot, not the big robots that we see all the time doing welding in the automotive lines. These are collaborative robots. They learn from humans with the cameras, and then they can mimic some actions that actually are helping the workers. And by doing that, throughput up to 40% is obtained. If every company is digitized, then we can put them all in the same cloud, and then we have what we have a digital supply chain. So we don't need to have stored products anymore. We can just order through the cloud, and everything will be shipped within the next hours. And then we have real data analytics, and basically just by improving our process, 10 to 20% improvement in quality and decreased cost can be obtained. With all this data, we can also increase the accuracy of demand. So how many products do we need to make by that day, next month? There used to be error in demand forecasting, and that error is because we are better and better in analyzing all our data. And then when we combine technologies, just computer engineering, simulation, more digital processes, 3D printing, we are actually faster, 30 to 50% to make prototypes and products. So with Digiman, we have had projects looking in some of these aspects in different sectors, as you will see today. And they all fall in some of these improvements. The reason why we wanted to do Digiman, and we think that's why we were successful in getting the attention of the European Commission, is that actually manufacturing is pretty big in Europe. It is known that all over the world, the amount of people employed in manufacturing has been going down. If you look at 100 years ago with the old industrial revolution, but productivity has been going up. So around 9%, and this is the latest, as you can see, year in which this number has been crunched. I started monitoring this data from 2015, that was 2017, and now it's 2021. In the numbers from 23 will be released in 24 this year. It takes 2 years to crunch all these numbers, just to let you know. So anyway, these numbers are 1 year post-COVID. So in 2017, there were 2 million manufacturing companies in Europe, and now it's actually 2.1 million, which means a little more, not drastic improvement. I think the good news is that there are still at least 2 million companies in Europe just on manufacturing. So not employees, just registered companies. And they employ 30 million people, which is basically one mid-sized country. So that's a lot of people just working on one sector. I mean, sharing technologies and expertise and being that kind of professional. And prior COVID, they were 28.5. Now the difference is only 5%, but I would say the difference is 1.5 million, which is one city, twice the size of Zaragoza. So it's definitely, it's an important sector. And how much is worth that? Well, 8.3 trillion, which is 8,300 billion euros in manufactured value, net turnover. So of all the employees in Europe, manufacturing is around 16%. So 1 person every 6. And how much value is in that product once it's sold and produced? You know, from 5 trillion euros in 21 to 6 trillion in 22. So one of the reasons here is not that we are making more products in Europe. We are actually making them better, and they are sold at a higher price, generally speaking, which is where Europe is strong. You know, high quality and high value products. And in order to do them very well, digitalization is key. But of course, we are not alone in this achievements. For this global market, we have pressure on that. And Europe is trying to get more and more of that market share like everyone else. But also, the amount of people that are prepared to do this is actually limited. And that's why we need people like you that studied engineering and become good at it. And it's a global competition. So the best companies are always out there to look for the best people, no matter where they are coming from. So it's more and more a global thing. So Europe is there to expand the manufacturing technologies, how much and how well they can do, and how to be more sustainable. It's not enough to produce a lot of cheap products that are actually very expensive from an environmental point of view. Sustainability is key. In these challenges, there are also opportunities, and they are basically represented by digital technology. So as I have said before, but now in super summary, with digitalization, we can increase the product quality, we can increase the production quality, so less waste, less material, and less energy. We can be faster to market, and we can achieve absolute sustainability so that the manufacturing processes are actually sustainable and are not using too much of our environment. By doing all these things, we are more agile, so we can move faster. We can be resilient, so we can respond to drastic changes, like a pandemic, for example, and we can become more sustainable. These 3 circles, these are this is called the triple sustainable bottom line. So any technologies, any product that has to be good for the people, and it has to be good for the planet, and has to be good for the profit. And in this case, the idea is this one: not to become richer, but of course, a profitable company will keep existing, and it's gonna still give to up to 30 million people, as I shown before. You know, and these are the conditions basically. Good. So among all the things that need to come in place in order to achieve this, we boil down to one key idea to tell, you know, the politicians. Say, we can be very good with technologies, maybe, but if we don't have the people, we don't go anywhere. All right. So, and this has been proven, and we have done our research. So manufacturing firms suffer the lack of skilled people that are able to adopt relevant digital technologies and implement them in manufacturing companies. So by joining our forces, so universities with 20 companies in DIGIMAN, we have made, of course, a limited small situation, but still we have created a number of, or trained a number of young researchers in production engineering that are able to join manufacturing and digitalization. So we started on 1st of January 2019, and we went on for 5 years until the 31st of March 24. So this is the very last conference we are going to do, and we thank you, of course, for being here. So 3 main highlights, and you will see the details in the rest of the afternoon. So we looked at precision manufacturing processes, and part of the research was dedicated to develop them even better. And then the second one was to integrate digital technologies. I mean, the one that really fit the specific process. Once number 1 and number 2 were done by every DIGIMAN researcher, then they went back to their collaboration company and they tried on an industrial environment, on a pilot production, the concept that was developed in the first part of the project. And we try to do 0.3 as much as possible for all projects. The method how to achieve this, that sounds quite challenging, was this 70-20-10 approach. So that everyone should spend 70% of their time on core digital manufacturing technologies. 20% of the time was spent in learning and using complementary technologies. So not doing research, but really learn what they need to do. And then 10% was then spent on project workshops in order to quickly learn some key enabling technologies that were needed in order to do the research. Now, if we extend this concept to all our 15 projects, we have some key technologies that are research topic here, key enabling manufacturing technologies, and then some complementary technology learned along the way. We were 6 training partners, so DTU from Denmark, KIT from Germany, Techniker near Bilbao, the University of Zaragoza here, the Polytechnic of Milan in Italy, and the University of Pisa in Italy. And this is the list of all the companies involved, and they were assigned to specific projects. And here we have made a list of the key industrial applications that were used as a case study for all the projects from 1 to 15. So there were 15 projects inside DIGIMAN. We have clustered them in 5 main clusters that refer to those key technologies around Industry 4.0. So we did not claim that we were going to do everything, but really focus on what was important in our industrial network. So we selected additive manufacturing, big data, analytics, simulations. We had quality control 4.0, digital supply chains, and cobots, collaborative robots. So we had either 2 or 3 single projects in each of these technology clusters. So our partners were 20 for all the 5 countries involved in the project. And we were going from very large companies. You can see Ansaldo is basically the biggest energy company in Italy, and Bosch, very well known, Continental, down to smaller realities. For example, this small medium enterprise in Denmark, that's 100 employees. And Toy from Italy was actually at the beginning a startup, and now it has a few tens of employees. And then the others were kind of in the middle, a few hundreds up to 1,000 employees. So this is the group that started in January 2019. And at the end of that year, in October, we had the first workshops. So some of these smiley faces are some of the researchers that we employed in DIGIMAN. Here, hands-on workshop, and here a project management workshop. And then, as you know, something happened in 2020, so we had to stay at home. But everyone was employed, and when you do a doctoral study, you have really 3 years in order to finish your project. So we could not stop. So we went online. We have done a lot of data analytics for sure, simulations, virtual reality, programming, And a lot of training was done doing what we call webinars, by doing digital exercises, virtual project rooms, you name it. We all have lived that, so you know what I'm talking about. So this is just a screenshot, right? So fast forward in 2022, we were back in Denmark finally. So the guys and girls took some time to do some real team building, and here they got a go-kart competition just outside Copenhagen. And as you can see, everyone is very happy to have done that. It is true, it was not only about go-karting. We had 2 workshops. We had innovation, management innovation, and prototyping, I remember. Shortly after, here, this is in Milan, so end of 2022. This is what we call a project meeting. So everyone meet and have a presentation about the progress of their project. And here we were doing some co-working on our digital platform. So we were all connected to the same data management system we have to upload information and share files. And then basically the world was going back to normal. So we could fly to Italy, for example, in the spring of last year, just 1 year ago. We were there doing also another meeting to check the progress of all the researchers here. And then in June last year, we were back to Denmark. Many projects were basically in their final stage. So they were in a stage that is very close to what you are going to see today. And this was our first conference. Conference was actually part of a bigger program, 1 week at the Technical University of Denmark. 300 people came from all, and some also from abroad. And some of them joined our workshops. And this was then in December 23, our last project meeting. Our last final meeting will be tomorrow. And that's why we are here at the University of Zaragoza. That's very good. So thank you, Jose, for hosting us. And basically, that's where we are now. So thank you.